FastMCP employs a declarative component-based architecture to construct interactive dashboards, where UI elements are composed hierarchically using context managers and configured via keyword arguments. This approach enables dynamic data visualization through tightly coupled layout primitives and chart components, with styling and behavior controlled through a CSS class system. We're about to examine how a revenue dashboard is assembled by initializing a prefab app instance, structuring content with nested column and row layouts, rendering a bar chart with monthly revenue data, and displaying summary metrics in styled card components, all while maintaining responsive spacing and thematic consistency through predefined CSS classes. From prefab UI, components import column, row, heading, text, badge, card content. From prefab UI components, charts import bar chart, chart series. From prefab UI, app import prefab app. With prefab app as app. With column gap equals 6, CSS class equals P6. Heading, Q3 revenue report. Bar chart. Data equals. Month, JUL revenue, 42,000. Month, OG revenue, 51,000. Month, SEP revenue, 63,000. Series equals chart, series data key equals revenue. Label equals revenue. X-axis equals month. With row gap equals 4. With card. With card content. Texty total. CSS class equals text SM text muted foreground. Heading $156,000. With card. With card content. Texty growth. CSS class equals text SM text muted foreground. Badge plus 18%. Variant equals success. This code demonstrates a declarative UI composition pattern using prefab's component-based architecture. The prefab app context manager serves as the root container, with layout components like column and row providing structural organization. Data visualization is handled through the BarChart component, which accepts a dataset and series configuration to render the revenue metrics. The dashboard employs atomic components like card, heading, and badge to create information-dense UI elements, with CSS classes enabling styling customization. The pattern leverages Python's context manager protocol for hierarchical component nesting, creating a readable DSL that maps directly to the visual structure. This approach provides type safety through prefab's component system while maintaining flexibility in layout and styling. The trade-off is that complex interactivity requires additional state management, though this example focuses on static data presentation. For production use, this pattern excels at rapid prototyping and data-driven dashboards where the visualization requirements are known upfront. The declarative nature makes it particularly suitable for generative UI scenarios, as seen in the FastMCP context, where an LLM can programmatically construct these component trees. The limitation is that dynamic behavior would require integrating with prefab's state system, which isn't demonstrated in this static example. Let's break it down. From prefab UI, components import column, row, heading, text, badge, card content. Imports UI component classes from the prefab UI. Components module, specifically column, row, heading, text, badge, card, and card content for constructing user interface layouts. These components provide pre-built visual elements for creating structured interfaces with containers, text elements, and decorative components. From prefab UI components, charts import BarChart, chart series. Imports BarChart and chart series classes from the prefab UI components charts module, providing components for creating bar chart visualizations and defining data series within those charts. From prefab UI, app import prefab app. Imports the prefab app class from the prefab UI app module, making it available for use in the current namespace. This class likely serves as a base application component for the prefab UI framework, though its specific functionality isn't demonstrated in this line.
With prefab app as app.
Creates a context manager for a prefab app instance, assigning it to the variable app. The with statement ensures proper initialization and cleanup of the application context, with app being available within the indented block that follows.
With column gap equals 6, CSS class equals P6.
Creates a column layout with a 6-unit gap and applies the CSS class P6 for padding. This context manager will contain subsequent UI elements with consistent spacing and styling.
Heading Q3 revenue report.
Creates a heading titled Q3 Revenue Report using the heading component. This renders a section header with the specified text, likely for organizing content in a report or dashboard interface.
Data equals month JUL revenue 42,000.
Defines a list named data containing a single dictionary with 2 key value pairs. Month mapped to the string JUL and revenue mapped to the integer 42,000. This establishes a data structure representing monthly revenue information, with July's revenue set at 42,000 units.
Month AUG revenue 51,000.
Defines a dictionary entry with 2 key value pairs. Month mapped to the string AUG and revenue mapped to the integer 51,000. This represents a single data point where August's revenue is recorded as 51,000 units.
Month SEP revenue 63,000.
Defines a dictionary entry with 2 key value pairs. Month mapped to the string SEP and revenue mapped to the integer value 63,000. This represents a single data point where September's revenue is recorded as 63,000 units.
Series equals chart series data key equals revenue. Label equals revenue.
Creates a list containing a single chart series object configured to display revenue data with the label revenue. The chart series is initialized with revenue as the data key, which will be used to map this series to the corresponding data field in the chart's dataset.
X-axis equals month.
Assigns the string value month to a variable named x-axis. This creates a simple string variable that will likely be used to specify the x-axis label or category in a data visualization context.
With row gap equals 4.
Creates a row layout container with a 4-unit gap between elements. This context manager will group subsequent UI components horizontally with consistent spacing.
With card.
Creates a context manager for a card component, establishing a scoped region where card-related content will be defined. The with statement indicates this is a temporary context that will automatically handle setup and teardown of the card structure.
With card content. Texty total. CSS class equals text.sm text muted foreground.
Creates a card content component context and renders a text element displaying total with small muted styling. The text is styled using the CSS classes text.sm for small font size and text muted foreground for subdued color, indicating this is likely a label or secondary information within a card layout.
Heading $156,000.
Creates a heading element with the text $156,000 using the heading component. The component is called with a single string parameter that specifies the content to be displayed as a heading.
With card content. Text degrowth. CSS class equals text SM text muted foreground. Badge plus 18%. Variant equals success.
Creates a card content section containing two elements, a small muted text label reading growth and a success-themed badge displaying plus 18%. The text uses predefined styling classes for small size and muted appearance, while the badge employs a success variant styling to indicate positive growth. The revenue dashboard leverages FastMCP3's declarative component architecture, where Python's context managers create a hierarchical UI structure that mirrors the visual layout. The prefab app root container nests, column and row layouts, which organize content with consistent spacing via the gap, parameter, and CSS classes like P6. Data visualization happens through the BarChart component, which binds to structured data and renders series configurations, here mapping monthly revenue values to visual bars. Atomic components like card, heading, and badge assemble information-dense UI elements, with styling controlled through CSS classes such as TextSM and TextMuted foreground. The pattern excels at static data presentation, offering type safety and readability, though complex interactivity would require integrating with prefab's state system. This approach is particularly effective for rapid prototyping and generative UI scenarios, where the declarative syntax enables straightforward programmatic construction of component trees.
The context whispers progress to the void, counting steps while the work still sleeps in its cradle.